Find the intervals on which f of x is increasing and the intervals on which it's decreasing. Just like what we've done in the previous videos, the first step is to determine the first derivative. So step 1, determine the first derivative. Which means we need to differentiate this function, and if you differentiate this function, you'll end up with 3x squared. Step 2 is to find the critical points. Basically, those are the points where the first derivative is equals to 0. So step 2, find the critical points. And these are the points where first derivative is equals to 0. So the first derivative from our calculation above is 3x squared. Equate that to 0, which means x is equals to 0. And that is our critical point. Step 3, we need to evaluate the derivative between or on either side of the critical point. So we just have one critical point, which means that we'll find the signs of the first derivative on either side. So evaluate the derivative. On either side of the critical point, we just have one critical point, so that will be easy. Which means that we need to draw a sign diagram. And this sign diagram is for the values of x. And we just have one critical point, so that will be 0 there. We also need to find the signs of f dash x on this sign diagram, which means we need to pick test points on either side. For example, when x is -1, what will be the first derivative? Obviously, if you plug in -1, you'll end up with 3. Okay, so that will be 3. If you plug in 1, you'll end up with 3, which means the sign of the first derivative on either side of the critical point is positive. So step 4, we need to find the intervals where f of x is increasing. Okay, so step 4, find the intervals where f of x is increasing, because as you can see, the function is not decreasing. Okay, the signs are all positive. So we know that a function is increasing when the first derivative is greater than 0, and that's what's happening here. So which means that in this function, the function is decreasing when x is less than 0 and when x is greater than 0, because at x equals to 0, it's a stationary point. Okay, nothing is happening. So on either side of 0, the function is either increasing or decreasing. Example 4, the graph of the derivative of f is shown. Write down the intervals on which f is increasing or decreasing. So just by looking at the graph, we can see that on this portion here, we can see that the first derivative is greater than 0. And on this portion here, we can see that the first derivative is less than 0. So basically here is greater than 0, is greater than 0, but here is less than 0. So we know that a function is increasing when the first derivative is greater than 0. So you can say increasing that will be when x is less than negative 2. Actually, let me write it below here. So increasing when x is less than negative 2 and when x is greater than 4. Decreasing when x is between negative 2 and 4.